Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about a partially and totally ordered set. In our previous classes, we clearly discussed about the properties of a relation. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, partially ordered set, or simply we call it as POSET. So a relation is said to be partially ordered when we are going to say that a relation is going to be a partially ordered. If it satisfies, it has to satisfy three properties. What are those? It has to satisfy reflexive, anti-symmetric and transitive. If it satisfies these three properties, then we say it as a partially ordered set. So with example, we are going to understand it better. Let's take an example. A is equal to A comma B. For this set, we are going to write S is equal to set of all subsets of this set. So these type of examples we have done many in our previous classes. That's why we are not concentrating on this, how we are going to write set of all subsets of this set. So what are the set of all subsets of this set? A comma B, phi, set A, set B, set A comma B. So on this set, we are mentioning a relation R is equal to set S. Take this set. On this set, we have to relational operator subset. So our relation is a subset. So what's the elements that belongs to subset means? Phi subset of phi. Yes, we can take that pair, phi comma phi. Set A subset of set A. Yes, we can take the pair set A, set A. So our relation contains those type of pairs. Set A subset of set A comma B. Yes, these two pairs can be belongs to our relation. And one more point, set A not subset of B. So don't take this. These two elements are not going to pair up in our relation. So we need to check for our relation R is reflexive or not. Yes, it is reflexive. Reflexive means you take any element from our set. Yes, set S. Take X belongs to X means you take any element X that belongs to set X. Here we named it as S. Commonly we call it as X. X belongs to X. Then X comma X, this ordered pair should belong to our relation. For all the X values, you take any X value from this set, phi, subset of phi, yes, A, subset of A, B, subset of B, AB, subset of AB. So you take any element, you are going to get X comma X belongs to our relation. So we call our relation is a reflexive relation. So the ordered pairs that contains phi comma phi, A comma A, B comma B, A comma AB, all this AB comma AB, all this belongs to our relation. So it is a reflexive relation. Now coming to the next one, anti-symmetric. We need to check for the condition anti-symmetric. If X relates Y and Y relates X, then definitely you should have X equal to Y. If these two conditions happen, then X equal to Y. This has to be happen. In our example, let's take an example. Phi subset of A. Yes, X, Y. X relates to Y. See, X relates Y, but Y is not related to X because set A is not subset of phi. So the subset operator, if X subset of Y and Y subset of X, then definitely X equal to Y. Then only it happens, X subset of Y and Y subset of X. Then definitely X equal to Y. This is the subset property which we discussed in our sets examples. So X relates Y. Definitely if this is not equal, Y is not going to relate X. If these two happen, then only you have to check for X equal to Y. In our examples, it is not happening. If it happens, definitely X equal to Y, because those are sets. So that's why it is satisfying anti-symmetric property. Now coming to the next example, next property, transitive property, we have to check for. If x relates y and y relates z, then x relates z. This has to be happen. Yes, you take any three elements from our relation, phi subset of a subset of ab, then definitely phi subset of a comma b. You take any pair, it is going to happen. So our relation x, s comma subset is going to satisfy the three properties. We call that relation as a partially ordered relation, means POSET. So now coming to the next one, totally ordered set. We call POSET a totally ordered set. You have to understand this properly. So before you check for totally ordered set, first you need to check for partially ordered set. If it is POSET, then only you have to check for totally ordered set condition. So totally ordered set condition will be checked on POSETs. First it should be partially ordered set, meaning it has to satisfy three properties: reflexive, anti-symmetric, transitive. So we call a POSET as a totally ordered set if every pair of elements has a relation. You take any two elements from our set, the two elements should have a relation. Any two elements from our set, the two elements should have a relation. A comma b, if it is having a relation, if you take any two elements, a comma b, it should have either a relates b or b is in relation with a. It has to satisfy any one of these. Then only we say it as a totally ordered set. With example you are going to get clarity. See the above example, it is a POSET. This is a POSET. We call this relation as a POSET. You take any two elements, a, b. We don't have a relation between these two elements. A is not subset of b. That's why we cannot call this as a totally ordered set. You take any two elements, you should form a relation, either a comma b or b comma a. That is what totally ordered set means. With example, we take this example. See, let's take that a is equal to set of all real numbers. Real numbers means you take it from minus infinite to plus infinite. Our relation r is equal to a comma less than or equal to. Our relational operator is less than or equal to. It is a totally ordered set. First we need to check for whether it is a POSET or not. Yes, it is a POSET. We are not again explaining whether it is a POSET or not. You try to do it. You check for reflexive, transitive and anti-symmetric. It is a POSET. After that you have to check for totally ordered set or not. Take any two elements, we will have the pair in relation. Yes, we will have that pair in relation. Why we are going to have that in our relation? A is equal to minus infinite to plus infinite. You take any two elements from this set. You take 0 comma 1, you take 0 comma 2, you can take 0 comma 0, you take 1 comma 2, you take minus 1 comma 1, minus 1 comma minus 2. Any two elements, those two elements will definitely placed in our relation. Why? Because our relation is 0 less than or equal to 1. Our relation is less than or equal to. Definitely two elements, either less than, one element will definitely be less than or equal to. 5 less than or equal to 6. You take any two elements, you will have a relation. That is what the meaning of totally ordered set. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.